Hi, I'm just going to finish off question 3, part A on Taylor series. You can actually do part 2 and part 3 of this question without having done part 1. Of course, you're not going to get anywhere near the amount of marks because most of the marks are for part 1. Let's scroll it up a bit. But we're at part 2 now. So the question was, where f of x equals cos x, show that the Taylor series expansion for f of x in powers of x minus pi over 2 is f of x is cos x minus pi x minus pi over 2 over 1 factorial plus x minus pi over 2 cubed over 2 factorial minus x minus pi over 2 to the power 5 over 5 factorial plus x minus pi over 2 to the power 7 over 7 factorial. Right, I've done that in the previous video. Now the next part is determine the nth term of the series. To do that, you use the formula that's given in the back, and we use this here part, right? This is our nth term, but this is a general term for any series, so we have to adapt it to our series. So the x minus a part is going to be x minus pi over 2. So we've got that part sorted, right? And then for the f of a and the factorial and the power business. So what we have here is we have this is to the power of 1 when the factorial here is 1. And this is our first term, so that's n equals 1. The first term here, this is the second term, n equals 2. The third term, n equals 3. And the fourth term, where n equals 4. We have to find a relationship between the terms, which is the n value, and the powers and factorials. Whoops, not the guy. Well, here we go anyway. So when n is 1, our powers and factorials, the value is 1. When n equals 2, the second term, the power is cubed and the factorial is cubed, so it's 3. Sorry, second term, now that should be 2. On the third term, when n is 3, our power is to the power of 5 and the factorial is 5. And then when n is 4, the fourth term, our power is to the power of 7 and the factorial is 7. So you want to find a relationship between this, right? This one, you could say n equals 1 or n equals n. Here, when n is 2 and our powers are 3, you need to find a formula for that. Now, there's a selection of formulas. You could have 2n, 2n plus 1, n, n plus 1, things like that to experiment with. In our case, it's 2n minus 1 is the formula. 2n minus 1. Because if I multiplied this 1 by 2, so we'd have 2 when the n value is 1, minus 1 will give me 2 2's minus 1 is 1. Here, if I have 2 for the formula, the little formula that we're creating, it's going to be 2 times 2, because n is 2, the nth term, minus 1, which is 2 2's minus 1 is 3, and that will give us the power. In the next one, if I have 2, and my n value is 3, it's a third term. 2 3's are 6, minus 1 will give me 5. And it works the same way. 2 times the fourth term, 2 4's minus 1 is 7. So instead of having a value up here, so for the general term, we're not going to have a value of a number. We're going to write 2n minus 1. So the general term so far is x minus pi over 2 to the power of 2n minus 1. That will mean our powers are going to go up in odd powers, divided by 2n minus 1 factorial. That's nearly the whole general term sorted out. And you can put in for n is 1, n is 2, n is 3, and you will get these terms. But we haven't included the fact that it flips from minus to plus to minus to plus. Now, a way that you can create terms that flip from minus to plus and so on is to use powers of minus 1, because minus 1 to an odd power is equal to minus 1. So like minus 1 to the power of 1 is minus 1. minus 1 to the power of 3 is minus 1. But minus 1 to an even power is positive, or plus 1. So we'll have minus 1 squared, which is 1, minus 1 to the power of 4 is also 1. So if you look back up at our answer, the series, it starts with a minus there. So when n is 1, that means n is odd. We have a negative power. When n is 2, that's minus 1 squared. That's a positive power. When n is 3, it's minus 1 cubed. That's a negative power, and so on. So the only thing I'd have to add into this here, general term, would be, put it in red now then, minus 1 to the power of n. And that will flip the sign from plus to minus, and that is a general power. I wouldn't get too worked up about this because, it's probably worth 1 or 2 marks. That's about it, and that's the general term. Okay, now the third part. Use the first 4 terms in the series expansion for cos x to approximate cosine 3 pi over 4. I just pan down and insert that again. Insert that question again. Taylor's series. I might be inserting it, but God knows where it's going. Oh, there, it's over there. It's tiny. Sorry about that. Here we go. Right. So, use the first 4 terms. They're already given because we're given the answer there. And we just have to, in this expansion, to find cosine of x. So basically, cosine of x is our expansion, and we need to find cosine of 3 pi over 4. Therefore, x must equal 3 pi over 4. So you put 3 pi over 4 into this formula for x. Now, a quick way of doing this is to work out what's inside each bracket. Because it's the same, it's x minus pi over 2 inside each bracket, right? So that's the same as for x, 3 pi over 4 minus pi over 2. And that will give us pi over 4. 3/4 minus a half is a quarter. So pi over 4. So every time we have a bracket, we put in pi over 4. So then cosine of 3 pi over 4 is equal to minus. So for the bracket, we can just write pi over 4, which is x minus pi over 2, divided by 1 factorial, which is just 1, plus, again, inside the brackets, we can write pi over 4 cubed over 3 factorial minus pi over 4 to the power of 5 over 5 factorial and plus pi over 4 to the power of 7 over 7 factorial. It is an infinite series, so we can do a few dots, but we're not going to go any further than the first 4 terms. And if you put these values into your calculator, you will get 0 minus 0.707106, which is very close to the actual value if you're going to put cosine 3 pi over 4 into your calculator. 3 pi over 4. Now, it is an approximation, so I should have a squiggly line there. And that's your answer. 0.7 70716. Thanks.